Hello everyone, this presentation is about Agile software development. Topics such as Agile methods, plan-driven and Agile development, extreme programming, Agile project management, and scaling Agile methods will be discussed under the Agile software development. Today, the software is part of almost all business operations. So, new software is developed and delivered quickly as possible to take advantage of new opportunities. Because these businesses are operating in a changing environment, it is often practically impossible to derive a complete set of stable software requirements. When we think about the rapid software development, specification, design, and implementation are interleaved. Since it is practically impossible to produce a set of stable software requirements, the system is developed as a series of versions with stakeholders involved in version evaluation. Today, most of the user interfaces are developed using integrated development environments and graphical tool sets, which has made the software development process more rapid than ever before. We know agile methods are not only used by the SMEs, meaning small and medium sized companies, but also the industry giants such as Apple, IBM, Microsoft, etc. With that said, dissatisfaction with the overheads involved in software design methods of the 1980s and 1990s led the creation of agile methods. Some of the key changes in agile methods compared to those previous methods are focus on the code rather than the design. Methods are based on an iterative approach to software development. Methods are intended to deliver working software quickly according to the changing business requirement. The agile methods allowed the development team to focus on the software itself rather than on its design and documentation. Agile methods universally rely on an incremental approach to software satisfaction, development, and delivery. They are best suited to application development where the system requirements usually changes rapidly during the development process. The Agile Manifesto is a document that identifies four key values and 12 principles that many of the leading developers of these methods believe software developers should use to guide their work. Here, according to the manifesto, the key four values individual and interactions, working software, customer collaboration, responding to change, which are bolded in the left, have more value than the items on the right. This slide describes some of the agile principles in a simple way. When we think about the customer involvement principle, it implies that the customers should be closely involved throughout the development process. Their role is provide and prioritize new system requirements and to evaluate the iterations of the system. Incremental delivery principle says that the software needs to be developed in increments, including the customer specifying the requirements in each increment. People, not process, implies that the skill of the development team should be recognized and exploited. Team members should be left to develop their own ways of working without prescriptive processes. Embrace change implies that we should expect the system requirements to change and so design the system to accommodate these changes. Finally, we can maintain the simplicity by focusing on simplicity in both the software being developed and in the development process. Furthermore, it says we should actively work to eliminate complexity from the system whenever it is possible. Let's consider the applicability of the agile methods. We can apply agile methods for product development where a software company is developing a small or medium-sized products for sale. We can apply agile methods for custom system development within an organization easily if there is a clear commitment from the customer to become involved in the development process and where there are not a lot of external rules and regulations that affect the software. Since agile methods are focused on small, tightly integrated teams, we cannot apply them to the large systems due to the problems in scaling of agile methods in order to get the same amount of advantages. There are some other problems associated with agile methods as well. Sometimes it can be difficult to keep the interest of customers who are involved in the process. Although the idea of customer involvement in the development process is an attractive one, its success depends on having a customer who is willing and able to spend time with the development team and who can represent all system stakeholders. Frequently, the customer representatives are subject to other pressures and cannot take full part in the software development. Individual team members may not have suitable personalities for the intense involvement that is typical of agile methods and therefore not interact well with other team members. Prioritizing changes can be extremely difficult, especially in systems for which there are many stakeholders. Typically, each stakeholder gives different priorities to different changes. As we know, maintaining simplicity requires an extra work. Under pressure from delivery schedules, sometimes the team members may not have time to carry out desirable system simplifications. Another non-technical problem that is a general problem with incremental development and delivery occurs when the system customer uses an outside organization for system development. The software requirements documents is usually part of the contract between the customer and the supplier because incremental specification is inherent in agile methods. Writing contracts for this type of development may be difficult. Consequently, agile methods have to rely on contracts in which the customer pays for the time required for system development rather than the development of a specific set of requirements. So long as all goes well, this benefits both the customer and the developer. However, if problems arise, then there may be difficult disputes over who is to blame and who should pay for the extra time and resources required to resolve the problem. Most books and papers that describes agile methods and experiences with agile methods talk about the use of these methods for new system development. However, a huge amount of software engineering effort goes into the maintenance and evolution of existing software systems. There are only a small number of experience reports on using agile methods for software maintenance, and there are two questions that should be considered when considering agile methods and maintenance. The first question is, are systems that are developed using an agile approach maintainable? Given the emphasis in the development process of minimizing formal documentation. Here, a formal documentation is supposed to describe the system and so make it easier for people changing the system to understand. In practice, however, formal documentation is often not kept up to date and so does not accurately reflect the program code. For this reason, it is a waste of time to write this documentation. The key to implementing maintainable software is to produce high quality readable code. Agile practices therefore emphasize the importance of writing well-structured code and investing effort in code improvement. Therefore, the lack of documentation should not be a problem in maintaining system developed using an agile approach. The first fact is that the problems may arise if original development team cannot be maintained. Agile methods rely on team members understanding aspects of the system without having to consult documentation. If an agile development team is broken up, then this implicit knowledge is lost, and it is difficult for new team members to build up the same understanding of the system and its component. And the second question is, can agile method be used effectively for evolving a system in response to customer change requests? Well, agile practices used in the maintenance process itself are likely to be effective whether or not an agile approach has been used for system development. Incremental delivery, design for change and maintaining simplicity all make sense when software is being changed. In fact, we can think of an agile development process as a process of software evolution. Agile approaches to software development consider design and implementation to be the central activities in the software process. They incorporate other activities such as requirements, elicitation, and testing into design and implementation. By contrast, a plan driven approach to software engineering identifies separate stage in the software process with outputs associated with each stage. The output from one stage are used as basis for planning the following process activity. In a plan-driven approach, iteration occurs within activities with formal documents used to communicate between stages of the process. For example, the requirements will evolve and ultimately a requirements specification will be produced. This is then an input to the design and implementation process. In an agile approach, iteration occurs across activities. Therefore, the requirements and the design are developed together rather than separately. As you can see, this shows the distinctions between plan-driven and agile approaches to the system specification. Most software projects include practices from plan-driven and agile approaches. To decide on the balance between a plan-based and agile approach, we have to answer a range of technical, human, and organizational questions. It is important to have a very detailed specification and design before moving to implementation. If so, you probably need to use plan-driven approach. Is an incremental delivery strategy where you deliver the software to customer and get rapid feedback from them If so, consider using agile methods. How large is the system that is being developed? Agile methods are most effective when the system can be developed with a small co-located team who can communicate informally. This may not be possible for large systems that require larger development teams, so a plan-driven approach may have to be used. What type of system is being developed? Systems that require a lot of analysis before implementation, for example, real-time system with complex timing requirements, that usually needs a fairly detailed design to carry out this analysis. A plan-driven approach may be best in those circumstances. What is the expected system lifetime? Long lifetime systems may require more design documentation to communicate the original intentions of the system developers to the support team. However, supporters of agile methods rightly argue that documentation is frequently not kept up to date and it is not of much use for long-term system maintenance. What technologies are available to support system development? Agile methods often rely on good tools to keep track of an evolving design. If we are developing a system using an integrated development environment that does not have good tools for program visualization and analysis, then more design documentation may be required. How is the development team organized? If the development team is distributed or if part of the development is being outsourced, then you may need to develop design documents to communicate across the development teams. You may need to plan in advance what these are. Are there cultural issues that may affect the system development? Traditional engineering organizations have a culture of plan-based development, as this is the norm in engineering. This usually requires extensive design documentation rather than the informal knowledge used in agile process. How good are the designers and programmers in the development team? It is sometimes argued that agile methods require higher skill levels than plan-based approaches in which programmers simply translate detailed design into code. If we have a team with relatively low skill levels, we may need to use the best people to develop the design with others responsible for programming. In reality, the issue of whether a project can be labeled as plan driven or agile is not very important. Ultimately, the primary concern of buyers of a software system is whether or not they have an executable software system that meets their needs and does useful things for the individual use or the organization. In practice, many companies who claim to have used agile methods have adapted some agile practices and have integrated these with their plan driven processes. Is the system subject to external regulation? If a system has to be approved by an external regulator, example, the Federal Aviation Authority FAA, approve software that is critical to the operation on aircraft, then you will probably be required the produce details documentation as part of the system safety case.
Let's take a look at extreme programming. Extreme programming is considered as one of the most widely used of the agile methods. This approach is developed by pushing iterative development to extreme levels. Iterative development is recognized as a good practice which is widely used in most of the software development process. For example, in extreme programming, several new versions of a system may be developed by different programmers, integrated and tested in a day. New versions may be built several times per day, and the increments are delivered to customers in a period of 2 weeks. When we look at the tests that are carried out for these new built versions, these tests must be successfully executed when new code is integrated into the system. There is a short time gap between releases of the system. So these are some of the characteristics of extreme programming. Now let's see how extreme programming and agile principles work together. We already know incremental development is a core characteristic of extreme programming. It is supported through small and frequent system releases. The requirements are based on simple customer stories, and they are used as a basis for deciding what functionality should be included in a system increment. When you look at the customer involvement, it is supported through continuous engagement of the customer in the development team. The customer representative take part in the development and also is responsible for defining acceptance tests for the system. The people are supported through pair programming. They also have the collective ownership of the system code. They work in a sustainable development process that does not involve excessively long working hours. Change is embraced through regular system releases to customers. Refactoring is used to avoid code degeneration, and continuous integration of new functionality is done all the time. Maintaining simplicity is supported by constant refactoring, and this also improves the code quality. This shows the extreme programming release cycle. The figure illustrates the extreme programming process to produce an increment of the system that is being developed. Extreme programming involves a number of practices which reflect the principles of agile methods. Let's take a look at these practices in more detail. First, we'll take incremental planning. The requirements are recorded on story cards which are collected from the customers, and these stories to be included in a release are determined by the time available and their relative priority. The developers break these stories into development tasks, and these tasks are further planned with testing and integration for a further updated release. Small releases happen in this process. When doing a release, what is considered is the useful set of functionality that provides a better business value is developed first. And these releases of the system are done frequently and incrementally adds functionality to the first release. Another practice is that the simpler design. Enough design is carried out to meet the current requirements. And these designs do not unnecessarily anticipate future changes to the system. Test first development is another practice. An automated unit test framework is used to write tests for a new piece of functionality, and the tests are carried out before the functionality itself is implemented. Refactoring is another process. All developers are expecting to refactor their codes accordingly when there are possible improvements, and this keeps the code simple and maintainable by doing these refactoring processes. Pair programming practice means the developers are working in pairs. They have the freedom to check each other's work and provide their insights in a supportive way to make the job a better one. Collective ownership means that the pair of developers work on all areas of the system. So there is no one special developer who is expert in everything, and all the developers take the same responsibility for all of the code they write. And anyone has the ability to change anything if they desire it's best for the system. Continuous integration means when a work on a task is complete, it needs to be integrated into the whole system. And after such integration, all the unit tests for that system must pass in order to decide that the task is complete. Sustainable pace means large amounts of overtime are not considered acceptable, which says that the developers are working in a sustainable development process that does not involve excessively long working hours. On-site customer means a representative of the end user of the system should be available full-time with the extreme programming team. So in the process, the customer is a member of the development team and he is responsible for bringing the system requirements to the team for implementation. Requirement scenarios also means the involvement of the customer in the development process. In extreme programming, a customer is a part of the team which is responsible for making the decisions on requirements. The user requirements are expressed as scenarios or user stories, and these stories are then broken down by the development team into implementation tasks. These tasks are the basis of schedule and cost estimates, and the customers choose the stories for inclusion in the next releases based on their priorities and the schedule estimates. Here is a sample story provided by an end-user customer about prescribing medication. This includes the functionalities that the customer expects from a software like this. So what the developer needs to do is he needs to identify the functions that the customer expects and they need to develop on it. For that, the development team needs to break down the story into separate tasks they need to fulfill. For example, a task can be dose checking. What dose checking is, it is a safety precaution to check that the doctor has not prescribed a dangerously small or larger dose. By doing these tasks and improving them, the developers can make a better application that provides the user needs. Now let's take a look at how extreme programming will cope with the future changes. The traditional software engineering says that you should design for change. That is, you should anticipate future changes to the software and design it so that these changes can be easily implemented. But extreme programming, however, has discarded this principle on the basis that designing for change is often wasteful. It isn't worth taking time to add generality to the program to cope with change. Therefore, the extreme programming approach accepts that changes will happen and reorganize the software when the changes actually occur. So for that, it uses a method called refactoring, which will be explained in the next slides. Extreme programming suggests that refactoring should be done constantly. This means that the programming team look for possible improvements to the software and implement them immediately. When a team member sees code that can be improved, they make this improvement even in situations where there is no immediate need for them. The changes are easier to make because the code is well structured and clear. Anyways, some of these changes might require hardware refactoring, so that can be a much more expensive effort. So as examples of refactoring, we can identify reorganizing of a class hierarchy to remove duplicate code, because duplicate code can make the software reused in an inappropriate way, and also the overall structure will degrade because of duplicate codes, and this can be fixed by using reorganizing of a class hierarchy. And another example is tidying up and renaming attributes and methods to make them easier to understand. And the replacement of inline code with calls to methods that have been included in a program library is another example where refactoring is used. Let's take a look at the key points we have identified from the content we have covered so far. We first discussed about the agile methods and identified it as incremental development methods that focuses on rapid development. It uses frequent releases of the software, which reduces the process overheads and also produces high quality code. They also involve the customers directly in the development process and get their uh, opinions to make the final outcome a better one. The decision on whether to use an agile or a plan-driven approach was discussed, and it actually depends on the software that is being developed, and also it depends on the capabilities of the development team and the culture of the company developing the system. We also discussed about extreme programming as a well-known agile method that integrates a range of good programming practices such as frequent releases of the software and also continuous software improvements, and how the customer participation in the development team affects the final outcome. Testing in extreme programming plays a crucial role. Since XP is an incremental development process, there is no system specification that can be used to develop system tests. So some approaches to incremental development have a very informal testing process. To avoid some of the problems of testing and system validation, extreme programming emphasizes the importance of program testing. So XP includes an approach to testing that reduces the chances of finding new errors into the current version of the system. To fulfill that, extreme programming has developed an approach where the program is tested after every change has been made. Here below are the key features of extreme programming testing. Test first development, incremental test development from stories, user involvement in test development and validation, and automated test harnesses. In the next slide, we'll look into detail about these features. Test first development is one of the most important innovations in extreme programming. Instead of writing some code, you first write the testing codes. This means that you can run the test as the code is being written and discover problems during development. Tests are written as programs rather than data so that they can be executed automatically. Also, these tests include a check so that we can prove it has executed correctly. Usually, these relies on testing frameworks such as Unit. And furthermore, this test-first development approach also avoids the problem of test lag. This may happen when the developer of the system works at a faster pace than the tester. The implementation gets further and further ahead of the testing, and there is a tendency to skip tests. So this can be avoided by using this test-first development so that the development schedule will be maintained. Let's see how customers involve in testing process. The role of the customer is to help develop acceptance tests for the stories that are to be implemented in the upcoming releases of the system. The customers are a part of the testing team, so when new code is deployed, it needs to be validated to ensure that it is what the customer expects. However, it is a bit difficult to rely on the customer to support to these acceptance tests. That is because they cannot work full-time with the development teams with their busy schedule. So sometimes they feel that providing the stories to the development teams is enough of involvement. So the companies might not rely majorly on the customers in the testing process. Here you can see in the slide a test case description which was prepared for dose checking task. The dose checking task was extracted from the story card for prescribing medication, which we have looked into in the earlier slides. Here the test cases are developed so that they can be used to check the implementation described in the task. So when the prescribed dose of a drug does not fall outside of the known safe limits, the output will indicate OK or error message appropriately. Test automation is essential for test-first development. These tests are written as executable components, and they should be able to simulate the submission of input to be tested, and also should check that the results meet the output specification. These executable components are written before the task is implemented. An automated test framework which is widely used is UNIT. It is a system that makes it easy to write executable tests and submit a set of tests for execution. As testing is automated, there is always a set of tests that can be quickly and easily executed. Whenever any functionality is added to the system, the tests can be run and problems that the new code has introduced can be caught immediately. Let's take a look at the difficulties faced by extreme programming testing. Most of the programmers prefer programming over testing. Due to that, they try to take shortcuts when writing tests, and they spend more time on doing the programming part. For example, they might write incomplete tests, which might lead into checking only some of the possible exceptions that might occur. So when going further in the extreme programming process, they might face difficulties due to lacking of proper testing. And another scenario is some tests can be very difficult to write incrementally. For example, in a complex user interface, it is difficult to write unit tests for the code that implements the display logic. And another scenario we can look at is the difficulty to judge the completeness of a set of tests. Although you might have a lot of system tests, your test might not provide the complete coverage. And those are some of the difficulties we can identify in extreme programming testing.
Pair programming. Pair programming is one of the key principles in extreme programming. Here, the meaning of pair programming is two programmers are working at the same piece of software. They are developing together. So they sit together at the same workstation to develop this software. That is pair programming. This pair programming has several advantages. The first thing is this helps to develop the common ownership of the code. You know, the common ownership is also one of the key concepts in extreme programming. This common ownership means after developing the whole software, this software is owned by the whole team members, all the team members. That's true that all the parts of the codes are developed by separate people in the team. But after developing, everyone has the responsibility of the code. Everyone owns the code. That's the meaning of this common ownership. So working as a pair always increases this common ownership because every time when you are programming, you share your program with the other one. Because of this pair programming spreads the knowledge across the team. And when pairs are made, if you are working in a extreme programming system, you will not find the same person as your partner every time. They will dynamically create the teams every day, and everyone gets the chance to work with everyone in the team. Because of that, this spreads knowledge across the team. And the other thing is, it serves as an informal review process as each line of code is looked by more than one person. When you are programming, the partner is always looking at the program, and if she or he finds an error, the bug, he can always show you. It's a very successful method of reviewing, because the other person is always looking at the code, and when she sees a bug in a code, she or he can show you the bug. And the other thing is, pair programming encourages refactoring. As a whole team can benefit from this. The refactoring is also improved by the pair program, because when you are developing your code, when you are programming, as the partner is looking at your code, you are programming such that your code is readable. Because of that, readability is improved. You will be renaming your attributes with meaningful words. You will add comments because someone is looking at the code and he or she can understand if I use this technique. And the other thing is, when you are programming duplicate codes, that the partner will also notice that and will show you to remove the duplicate codes. That is also something very important for refactoring. So I think this refactoring, which is a process of software improvement, is encouraged by this pair programming, because readability will be improved and the quality of the code will be also improved. When you are thinking about the pair programming, you will think that two people are developing a piece of software, and that is inefficient because two people are engaging in the same work together. So, but the reality is not that. The measurements suggest that development productivity with pair programming is similar to that of two people working independently, and I can say that is more than that of two people working independently, because this pair programming has a lot of advantages, because when you are working as a pair, these two people discuss the software before development. So probably they have fewer false starts. Because of that, it will reduce the rework, because if you are working as an independent programmer, you will develop the code, and when you are working with the code, then you will understand there is a bug and the way I started the program is incorrect. Then you will have to do it again, and that will consume a lot of time. But when you are working as a pair, the other person always show you the bugs, and if you have started in an incorrect way, and you can discuss and do it, then because of that you can improve the efficiency and the productivity when you are working as a pair. As I said before, in pair programming, programmers sit together at the same workstation to develop the software. So they are developing the software together. So, and this point also I said before, pairs are created dynamically so that all team members work with each other during the development process. So if you are working in such a system, you will not find the same partner always. You will have different partners in the team to work. The other thing is the sharing of knowledge that happens during pair programming is very important, as it reduces the overall risk to a project when team members leave. That is very important thing, because if someone resigns from their work, the other person, the partner, especially the partner, knows what he was doing, what he was programming. So that person can continue the work, although the other person resigned from the work. And at this point also, I said before, pair programming is not necessarily inefficient, and there is evidence that a pair working together is more efficient than two programmers working separately. So because of the bugs and done by these programmers, the time will be consumed more when you are programming independently. But when you are working as a when you are working as a pair, the other person always looks at your code and you can find bugs. And the other thing is, when you are developing, first you will discuss together how to develop this. Because of that, you will not have false starts. You will always have correct starts, and um, there will be less rework because of that. In the previous two slides, we looked at what is pair programming and the advantages of pair programming. And this slide is kind of a summary of the things we talked. Let's look at the advantages of pair programming briefly. So the first thing is it supports the idea of collective ownership and responsibility for the system. So we know what is collective ownership and responsibility. The whole software is owned by all the team members, and if you find a bug in the software, the particular person who developed that piece of code is not responsibility for that bug, but all team members are responsible. That is collective ownership and responsibility, and these principles are improved by the pair program. And the other thing is, it acts as an informal review process, because each line of the code is looked at least by two people. And the other thing is, it helps to support refactoring. It improves the readability. It improves the quality of the program, which is a process of software improvement. So these are the advantages of pair programming, and we have looked at what is pair programming and the advantages of pair programming. In this section, we are going to look at the Agile project management. So let's look at what is the responsibility of the software project manager. The main responsibility is to manage the project so that the software is delivered on time and within the planned budget for the project. The next thing is, the standard approach to the project management is plan driven. Managers draw up a plan for the project, showing what should be delivered, when it should be delivered, and who will work on the development of the project deliverables. A plan-driven based approach really requires the manager to have a stable view of everything that has to be developed and development processes. However, it does not work well with the agile methods, because in there the requirements are developed incrementally, where the software is delivered in short, rapid increments, and where changes to the requirements and the software are the norm. So, like every other professional software development process, agile development has to be managed so that the best use is made out of the time and resources available to the team. So this requires a different approach to project management, which is adapted to incremental development and the particular strengths of the agile method. So here we are going to discuss about a particular agile method named Scrum, which will provide a project management framework for the agile system. So in next slides, we are going to look at the method Scrum and its process. Okay, let's look at the Agile method Scrum, which provides the management framework for the project. So the Scrum approach is a general Agile method, but its focus is on managing iterative development rather than technical approaches to Agile software engineering. So actually Scrum does not prescribe the use of programming practices such as pair programming and test-based programming, right? It does not prescribe these programming principles. But what it does is it gives us a management framework. So we learned the Agile method, extreme programming, XP, in previously. Actually, that is a technical approach to Agile software engineering. So when we are doing a project, if we can make the use of these both of methods for the project, that would be very nice. And in the Scrum, there are three phases. In the Scrum process, there are three phases. The first phase, the initial phase, is outline planning phase. Sorry, outline planning phase. Here, we identify the general objectives for this project and we design a software architecture. We are not going to do any developing thing in the first phase. We are just designing the software architecture. The developing is coming into the next phase, which is known as sprint cycles. Here, the development is done as increments, and each cycle develops an increment of the system. So this is actually the most important phase in Scrum. Okay. And the last phase is project closure phase, the end of the project, which completes the required documentation, and actually it gives the user manuals and gives the system health frames to the users, and that is the end of the project. That's project closure phase. In the next slide, we will look at the picture of overview of these three phases. That is the overview of these three phases. So the first phase is outline planning and architectural design, and the next phase, which is the central phase, the sprint cycle, where the development is taking place. Here, in one sprint cycle, there are four phases again: assess, and select, develop, and review. So we will be looking at these four phases and these four things and how they are working and the principles in there in next slide. And the last phase of this Scrum process is project closure. There actually we provide the required documentation, the user manuals for the customer, and that is the completion of the project. The next slide, we will look at the sprint cycles. Let's look at the sprint cycle deeply. Here, the sprint cycle, which is the second phase of the Scrum process, normally takes 2 to 4 weeks. Actually, they correspond to the development of a release of the system in XP. In the sprint cycle, we identify 4 phases. The first phase was assess. In this phase, what we do is we make a list of work to be done on the project. The second phase was selection. So what we do here is the project team work with the customer to select the features and functionalities to be developed during the sprint. That is done in the selection phase. Let's go to the next. Here, now in the second phase, the selection phase, we have selected the functionalities that will be developed. Then in the third phase is the development phase. Here, actually the developing team, the project team is isolated from the customer and organization. The team themselves organize to develop the software and they do the developing process. In this phase, all the communications are handled by someone called Scrum Master. This person actually protect the development team from the external distractions. And when they are working, normally they held some short daily meetings involving all team members. Actually, the intention of their meeting is to review the progress and they are working and to distribute the knowledge among them. And after that development is done, then they have the last phase, that is review phase. In there, the work done is reviewed and presented to the stakeholders. Then the next sprint cycle then again begins. So that is the sprint cycle process. So in Scrum process, the second phase is sprint cycle. There we have 4 stages. The first stage is assess, then second we have the selection, then we have the development, and last we have review. Again in the next sprint cycle, again you go to the first assess, like that the circle goes. So in the next slide we will be looking at the teamwork of the Scrum. Teamwork in Scrum. In the previous slide also I said about the Scrum Master. So actually he's a person who's a facilitator who arranges daily meetings for the development team. And you know, the Scrum Master comes into the picture in the development phase in the sprint cycle. You know, in this development phase, the developers, the programmers are not communicating with the customers and the organization. The Scrum Master is the person who communicates with customers and management outside the team. And then he takes the decisions and he tracks the backlog of work to be done. So what is the backlog is that the list of work to be done in the development period. And he takes record decision and he measures progress against the backlog, and he does so many works in the sprint cycle. And the other thing is in the development phase in this sprint cycle, the whole team attends short daily meetings. So where all team members share information, describe their progress, and they share all the information. And they discuss the problems they have. Everything is discussed in these daily meetings. Normally they're planned by the Scrum Master. Normally, because of this short daily meeting, all the development team can know what is going on and all the problems that have arisen. Everything is got to know in these meetings. So this is the teamwork in Scrum. Let's move to the next slide. Now let's look at the Scrum benefits. So the first advantage is the product is broken down into a set of manageable and understandable chunks. And the other thing is the unstable requirements do not hold up the progress. and the whole team have visibility of everything, and consequently team communication is improved, like they hold their daily meetings, and because of those things the communication is improved within the team, and the customers see on time delivery of increments and gain feedback on how the product works. Because of that, the trust between customers and developers is also established, and a positive culture is created in which everyone expects the project to succeed. Let's start this new topic, scaling agile methods. So agile methods were developed or used by the small programming teams who could work together in the same room and communicating informally. So agile methods have therefore been mostly used for the development of small and medium-sized systems. It is sometimes argued that the success of these methods comes because of improved communication, which is possible when everyone is working together. We looked at some principles in agile methods like extreme programming, that was pair programming, things like that. Actually, they improve the communication within the team. And scaling up agile methods involves changing the scope with larger, longer projects where there are multiple teams, development teams, perhaps working in different locations. Actually, the need for faster delivery of software, which is more suited to customer needs, also applies to large systems. Because of that, the scaling these agile methods to large systems is a trending topic for these agile methods. Let's go to the next slide. Now let's look at large systems development. So large systems are usually collection of separate communication systems where separate teams develop each system. So frequently these teams are working in different places, sometimes in different time zones. So it is practically impossible for each team to have a view of the whole system. Consequently, their priorities are usually to complete their part of the system without regarding for wider system issues. The other point is, the large systems are brownfield systems. That is, they include the interact with a number of existing systems. Many of the system requirements are concerned with this interaction and so don't really lend themselves to flexibility and incremental development. So the political issues can also be significant here. Often the easiest solution to a problem is to change an existing system. However, this requires negotiation with the managers of that system to convince them that the changes can be implemented without risk of to the system's operation. And the thing is, where several systems are integrated to create a system, a significant fraction of the development is concerned with system configuration rather than original code development. This is not necessarily compatible with incremental development and frequent system integration. Let's consider more about the large system development. The large system and their development processes are often constrained by external rules and regulations, limiting the way that they can be developed, that require certain types of system documentation to be produced, etc. And the large systems have a long procurement and development time. It is difficult to maintain coherent teams who know about the system over that period, as inevitably people move on to the other jobs and projects. And large systems usually have a diverse set of stakeholders. For example, the nurses and administrators may be the end users of a medical system, but senior medical staff, hospital managers, etc. are also stakeholders in the system. So it is practically impossible to involve all these different stakeholders in the development process. Now let's look at the next slide. Scaling out and scaling up. So first, let's look at the meaning of these two terms, scaling up and scaling out. So scaling up is concerned with using agile methods for developing large software systems that cannot be developed by a software team. And scaling out is concerned with how agile methods can be introduced across a large organization with many years of software development experience. Normally, when you are scaling agile methods, we have to keep the agile fundamentals. So the agile fundamentals are flexible planning, frequent system releases, continuous integration, good team communication, and test-driven development, things like that. So let's move to the next slide. Scaling up to large systems. For large system development, it is not possible to focus only on the code of the system. You need to do more upfront design and system documentation. The software architecture has to be designed, and there has to be a documentation produced to describe critical aspects of the system, such as database schemas, the work breakdown across teams, etc. And cross-team communication mechanisms have to be designed and used. This should involve regular phone and video conferences between team members and frequent short electronic meetings where teams update each other on progress, like that. A range of communication channels such as email, instant messaging, wikis, and social networking systems should be provided to facilitate communication. And continuous integration, where the whole system is built every time any developer checks in a change, is practically impossible when several separate programs have to be integrated to create the system. However, it is essential to maintain frequent system builds and regular releases of the system. So this may mean that new configuration management tools that support multi-team software development have to be introduced. Let's move to the next slide. Now let's look at scaling out to large companies. Project managers who do not have experience of agile methods may be reluctant to accept the risk of new approach, as they do not know how this will affect their particular projects. And large organizations often have quality procedures and standards that all projects are expected to follow, and because of their bureaucratic nature, these are likely to be incompatible with agile methods. Sometimes these are supported by software tools, and the use of these tools is mandated for all projects. Agile methods seem to work best when team members have a relatively high skill level, and however, within large organizations, there are likely to be a wide range of skills and abilities, and people with lower skill levels may not be effective team members in the agile processes. And there may be cultural resistance to agile methods, especially in those organizations that have long history of using conventional systems engineering processes. So that's all about this agile methods and processes. And let's move to the next slide. Okay. The key points in this lesson is first we look at the extreme programming concepts, the principles of extreme programming, and the extreme programming is one of the agile methods which use a technical approach to the project, and the particular strength of extreme programming is the development of automated tests before program feature is created. So all tests must successfully execute when the increment is integrated into a system. And some important principles used in this XP were also discussed, like pair programming, uh, collective ownership, things like that. And then we discuss about the Scrum method, which provides a project management framework for the project. And there we discuss about 3 phases. The first phase, the second phase, which is sprint cycle, and last one was the conclusion phase. There in sprint cycle we talked about a lot of things. About the sprint cycle also had 4 stages: the assess phase, then we went to the selection phase, then we do development phase, then after we went to review phase. Like that we discussed about them. And finally we talk about the scaling agile methods for larger systems, and we discussed that it is difficult and larger systems need upfront design and some documentation for that. So that's all about the agile development, and thank you.